Progressive Web Apps, or PWAs, represent the future of web application development. A PWA is a web application that provides users with an experience similar to a native mobile app, but it runs directly in the web browser. PWAs combine the best features of traditional websites and native applications, giving users the benefits of both technologies in a single solution. Progressive web apps offer 4 major benefits that make them increasingly popular. First, they are lightning fast. PWAs use advanced caching techniques to load instantly, even on slow internet connections. Second, they work offline. With a service worker running in the background, PWAs function completely without an internet connection. Third, they are installable. Users can add PWAs to their home screen just like native apps without visiting an app store. Fourth, they update automatically. PWAs are always up to date without requiring manual user intervention. 3 core technologies power every progressive web app. The first is the service worker, a background script that enables offline functionality and handles caching strategies. The second is the web app manifest, a JSON file that contains all the app metadata, including the app name, icons, colors, and installation settings. The third is HTTPS, the secure protocol that ensures all communication between the app and user devices is encrypted and protected from unauthorized access. Security is fundamental to progressive web apps. HTTPS is required for all PWAs, ensuring that every piece of data transmitted is encrypted. Content Security Policy, or CSP, is implemented through HTTP headers to prevent cross-site scripting and injection attacks. Additionally, all user data stored on devices is encrypted both during transmission and at rest, protecting sensitive information from unauthorized access or interception. Building a PWA involves 4 essential steps. First, set up HTTPS on your web server to enable secure communication. Second, build the app shell, which is the minimal HTML, CSS, and JavaScript framework that loads instantly. Third, register the service worker to handle offline functionality and caching logic. Fourth, add the web app manifest file to define all application metadata and enable the install prompt on user devices. Users experience significant advantages with progressive web apps. Instant loading is achieved through cache-first strategies that eliminate long wait times. Offline readiness means users can continue using the app even without internet connectivity. Push notifications keep users engaged with timely, relevant messages directly on their devices. Finally, PWAs deliver an app-like feel with smooth animations, intuitive navigation, and native app behavior, all within the browser. Despite their advantages, PWAs have some limitations to consider. Limited hardware access means PWAs cannot directly access advanced device features like biometric sensors or specialized camera capabilities. iOS constraints are significant because Apple's Safari browser has limited PWA support and PWAs cannot be distributed through the Apple App Store. Additionally, battery performance may be higher compared to native applications, which could impact user experience on devices with limited battery capacity. The future of progressive web apps is exciting. WebAssembly allows PWAs to execute high-performance code for complex computations, bringing them closer to native app capabilities. WebGPU technology enables advanced graphics and gaming functionality directly in the browser. Artificial intelligence integration means machine learning models can run directly within PWAs, enabling smart, personalized experiences. Cross-platform compatibility improvements will make PWAs seamless across web, mobile, and desktop environments. Developing a PWA follows a structured 6-step process. Step 1 is building a responsive website with HTTPS enabled to ensure compatibility across all devices. Step 2 involves creating the app shell, the minimal framework that loads instantly. Step 3 registers and configures the service worker for offline functionality. Step 4 adds the web app manifest file with all necessary metadata. Step 5 implements push notifications for user engagement. Step 6 completes testing and deployment to ensure quality and performance. Following best practices ensures PWAs are secure and robust. Always enforce HTTPS and implement HTTP strict transport security to guarantee secure communication. Use strong authentication methods like multi-factor authentication, OAuth 2.0, and JSON web tokens to control access. Apply content security policy headers to prevent cross-site scripting attacks and other injection vulnerabilities. Finally, audit all dependencies regularly and keep libraries updated to patch security vulnerabilities quickly.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.